Hi guys, welcome to the second part of 213, which deals with inequalities rather than equations. So these properties up at the top are going to be pretty important. So if b is greater than 1, then that means it's an increasing function. So that's like this graph right here, okay? And that says that essentially it's increasing for all x values, okay? So that would follow you if you had something like 2 to the x, that 2 to the third is less than 2 to the fourth. Okay, so the x is less than the y. However, if you have something that's a fraction between 0 and 1, okay, then you have something like 1/2 to the x, which is decreasing for all x values. Well, the bigger the exponent, the smaller the fraction, because it's a fraction. And so if your denominator gets bigger, then essentially that function is decreasing. It's a little bit weird to wrap your brain around at first. So on part A, the first thing I'm going to do is rewrite 125 as 5 to the third. And I know when I'm raising to a power, I can multiply the exponents. Now, this is an example of the number 1, where b is greater than 1. My base is 5. So it's just going to follow then that x is greater than 3x plus 18. I can subtract 3x from both sides and divide by -2. Remember, with inequalities, when you divide by a negative number, you're going to flip the sign. So you get x is less than -9, or you could write that as -infinity to -9. All right, let's look at part B. Same idea. I'm going to rewrite 1/27 as 1/3 to the third power. Remember, when you're raising to a power, you can multiply the exponents. All right, this is an example of exponential decay. It's going down, it's decreasing. So essentially what's going to happen when you set up your inequality is you're going to say 2x plus 9 is greater than or equal to 3x minus 9, because as my exponent increases, my function essentially gets smaller. So to solve this, I can minus 2x on both sides, and I get 9 is greater than or equal to x minus 9, add 9 to both sides, and so I get x is less than or equal to 18. Or you could write that as -18 or -infinity to 18 included. All right, so now let's look at some of these same properties, but this time with logs. Okay, so if b is greater than 1, meaning the base is greater than 1, then everything's just normal. And then x, the argument for x, is greater than the argument for y. If the base is between 0 and 1, then essentially, like I said, your signs are going to switch, because if I have a log function with a base less than 1, between 0 and 1, then that's just going to be decay. All right, so let's look at this right here. So first thing I'm going to do is use my power property to say that coefficient's really just an exponent. Okay, so I get something that looks like this. My base is greater than 1, so it's just going to follow then that 9 is greater than x squared. This one's a little bit tricky. We're going to have to use a quadratic inequality. So I'm going to get everything on the right side. And this is just saying x squared minus 9 is less than 0. Okay, so I can factor that, x plus 3, x minus 3, and make myself a little sign chart. Remember, the easiest way to do this is to plug in 0. So if I were to plug in 0 to x squared minus 9, I'd get 0 minus 9, which is negative. So 0 is right here, so that means anywhere in here is negative. The outsides would be positive. We are looking for where it is less than 0, which is where it is negative. So that would give me -3 to 3. All right, but we got to pause 1 second and make sure we don't have any extraneous solutions. So if I were to plug in -3, for example, that's fine. But this, I have log base 2 of a negative number. That's not going to work. Okay, -2 also wouldn't work. -1.5, not going to work. Remember, this will have to be greater than 0. So instead of saying -3 to 3, I'm going to do 0 to 3. Again, 0 can't be included because what's in the log can't equal 0. And 3 is not included based on my original. Okay, a little bit tricky there. Got to go back and check to make sure that your solution set does work. Remember, we didn't have to do that on these over here because exponential has a domain of -infinity to infinity. Okay. All right, so let's look at this right here. Okay, so because this base is greater than 2, we can rewrite this, or greater than 1, excuse me, it is 2. 2x plus 1 is less than or equal to 2 to the third, and I got that by putting it into exponential form. Okay, 2 to the third is just 8. So I get x is less than or equal to 7 halves. So that would give me something negative infinity to 7 halves. However, we're going to have a problem again because whatever's inside this has to be greater than 0. So let's see what that'll be. So I know that whatever's inside, it can't go all the way to negative infinity because it has to be greater than negative 1/2. So my final solution will look like negative 1/2 in parentheses because it's got to be greater than 0, all the way to 7 halves included. Okay, all right, let's look at one more. So this one right here, I notice that I have 2 logs, but my base is between 0 and 1. So essentially when I set up the inequality, because it's decay, it's going to look like 2x minus 3 is less than or equal to x plus 5. So if I'm going to go about solving this, I'm going to do subtract x on both sides, add 3, so x is less than or equal to 8. Okay, so that would be negative infinity to 8, but can it go all the way to negative infinity? Well, let's see. We know that both of these have to be greater than 0, so let's see which one is more restrictive. So that says 2x is greater than 3, x is greater than 3 halves. Then I have x plus 5 is greater than 0, x is greater than negative 5. Okay, so this one's more restrictive. So it's got to follow the more restrictive one, because if it's greater than 3 halves, then it's definitely greater than negative 5. So my final answer will look like starting at 3 halves, not included, because it has to be greater than that. And it's going to stop at 8 included, because that was or equal to. So again, you got to check both and pick the one that's more restrictive, because if it follows the more strict one, then it's definitely going to follow the easier one. Think about if you have 2 parents and one of them is really, really strict, if you follow their rules, then you're probably good with the other parent, or however you want to think about it. Okay. All right, so that takes you through 213 part 2, which deals with equations, was the first part of it, and then also solving inequalities as well. Have a great rest of your day.